Hello everyone, this is my KEW2046R. This is a true RMS AC-DC current clamp meter. This is made by the company KYORITSU in their plant in Thailand. It comes with a good pair of test leads measuring 110 millimeters from the elbow to the tips with removable covers. A certificate of conformity and instruction manuals in both English and Japanese. Also included is this very nice carrying case with a zipper and handle, and this is its retail box. Two AAA batteries were also included in the retail box, which I have already installed inside this battery compartment. These are the technical specifications of the KEW2046R. AC current up to 600 amperes. The 1000 amperes rating there refers to the other model KEW2056R. What I have here is the 2046R, so that would be 600 amperes. For DC current, also 600 amperes. AC voltage up to 600 volts. DC voltage also up to 600 volts. A resistance range up to 60 mega ohms. A continuity buzzer rated at 600 ohms, but the buzzer will sound at 100 ohms or less. A diode test voltage of 2 volts. Capacitor test function from 40 nanofarad to 4000 microfarad, although the guaranteed accuracy is between 400 nanofarad and 40 microfarads. Frequency is also available in AC current and AC voltage. Temperature function between minus 50 degrees Celsius to plus 700 degrees Celsius or minus 58 degrees Fahrenheit to plus 1292 degrees Fahrenheit. To conserve battery power, the device automatically powers itself off in about 15 minutes after the last function switch operation. The KEW Snap 2046R is capable of measuring temperature in degrees Celsius and degree Fahrenheit. However, the optional accessory called K-type temperature probe 8216 was not included in the retail package. So in my temperature test later on, I will use the FLUKE K-type thermocouple instead. The KEW2046R has a safety category rating of category 4, 600 volts AC-DC voltage and 600 amperes AC-DC current maximum. This is one of the best category safety ratings in its class. This is the device function selector switch. It appears to make a self-test, and after 2 beeps, measurements can already be taken. The selector dial has a nicely grooved rubber edges along this selector dial, and an arrow to clearly indicate which function it has selected. This is the function for the 600 ampere maximum AC and DC current, which can be toggled using the select button. For DC current measurement, the value can be reset to 0 using the 0 button. And that is indicated by the small triangle or delta sign in the display. AC voltage up to 600 volts, DC voltage up to 600 volts also, and this is the function for the resistor, diode, continuity and capacitor, which can be toggled using also the select button. And finally, the temperature function. The units of temperature can likewise be selected using the select button. either degree Fahrenheit or degree Celsius. The device defaults to degree Celsius. This is a good pair of high-quality flexible test leads, rated at 10 amperes and 600 volts category 4. The LCD screen has a big, bold digital display, which are easy to read. They also provided a digital bar graph to simulate an analog scale, which is a nice looking feature. This is the button to toggle frequency and duty cycle for AC voltage. So I'm getting a 59.92 Hz, and this is practically the nominal 60 Hz service voltage. Duty cycle of 49.8% and 233 volts, which is also indicative of the nominal service voltage of 230 volts AC and 60 Hz. The minimum and maximum button is used to capture minimum and maximum values within a monitoring period. The peak button is used to enable the peak hold function in AC current measurement. This is useful in capturing AC inrush current's peak values. The hold button will freeze the value on the screen. Data hold and backlight share the same button. To enable backlight, press and hold for 2 seconds. There is a red backlighting, which in dark locations provides a bright enough illumination to read the values clearly. The problem is that it lasts for only 10 seconds. The other limitation as far as backlight is concerned, once you hold the value on the screen and remove the test leads at the test points and turn on the backlight, the frozen value will disappear. The instrument will disengage the hold function. If you want to enable backlight at the same time hold the value on screen, first turn the backlight on and hold it, and then you have the value with the backlight on. The clamp meter's jaws are operated using this lever. Only one part is movable. One end has the metallic part exposed, while the other end is insulated. The instrument's Hall effect sensor is located here. There is also an arrow and plus sign at the bottom part of the jaws to provide guidance when using the clamp meter to measure DC current. This is used for properly orienting the clamp meter with the direction of the load when clamping the positive line. For AC current measurement, these are not necessary. It also has a non-contact voltage detection function, indicated by this red LED light, and the sensors for that are installed in this area. The NCV is automatically enabled whenever the device is turned on. However, it is not as sensitive as I'd hoped it would be. Unlike my other clamp meter, the KEW2147R has a much more sensitive NCV. This one's a better non-contact voltage detection function. In any case, I do not rely on NCV alone to detect the presence of voltage. When in doubt, it is always best to test voltage using the test leads in a safe and accessible location. There is a strip of rubber molding surrounding the sides of the body of the device, which should provide protection against minor bumps. Also a strap and a strap hole was provided. This is the battery compartment cover with warning signs and country of manufacture, made in Thailand. Serial number. Two AAA batteries provide power to the instrument. These were included in the retail package. Here are some of the things that I liked about the KEW2046R. It is very versatile and easy to use. A true RMS digital clamp meter that has the most important multimeter functions in a convenient package that can also measure AC and DC current, plus frequency, capacitance, diode, and temperature. It has peak hold function. It can capture Inrush current's peak value. That can prove useful in configuring protective devices based on AC current's peak values. Although I don't have the facilities to show you, the KEW2046R should be right at home in DC power systems, like solar power, UPS systems, electric vehicles, and charging stations. Here are some of the things that I wasn't too excited about. I observed that AC current measurement of low values was rather slow. I noticed this when I compared its readings with the readings of my other clamp meters when testing AC current in the range of about 3 amperes AC to 6 amperes AC. It was also lower by about 0.5 amps, which should not be much of a concern if you're troubleshooting. But if you're trying to configure a small protective device based on high resolution accuracy, this can be an issue. Current above 6 amperes AC, however, were displayed with minimal delay. There are no problems there. I have no problem with the red backlighting of the KEW2046R. It actually illuminated the screen of the instrument quite well, making the display quite easy to read. The problem is the duration of the backlight, which is a mere 10 seconds. I think it is simply not enough. I believe that this is an inconvenience that should really be addressed by the manufacturer in the next update of this clamp meter. A separate backlight button would be much welcome, and perhaps a more modern white LED backlight should be used instead of red. An AC-DC current clamp meter is really one of the essential tools in the arsenal of the electrical practitioner who deal with AC power systems and also DC power systems. Overall, in my limited test, I think that the KEW2046R has done rather well. I do hope, however, that the manufacturer in future versions of this device would improve the speed and accuracy of AC current measurement, would install a separate backlight button, perhaps also design a pair of jaws thinner than this, and improve the non-contact voltage detection, and perhaps also include a low-pass filter, which facilities maintenance personnel who deal with adjustable speed drives would certainly appreciate. Thank you for watching.